Hey guys, let's see how we can solve question 65 from the second chapter of the Beer Johnston textbook, Engineering Mechanics, and we have three forces that are applied to a bracket at point A. We know the directions of the 250 Newton forces may vary, but the angle between these two forces is always 50 degrees. So we are talking about the angle between the 250 Newton force. And we need to determine the range of values of alpha for which the magnitude of the resultant of these two forces is less than 600 newtons. So what we can do in here, we can find the resultant of the 250 forces that we have. And after that, we can find the resultant of the 500 newton and the resultant of these two forces. So let's go with that first. So if we want to find the resultant of that, we can either use the parallelogram or triangle rule. And we're going to call the resultant of these two R1. And we know this angle is 25 degrees. And because we have the same sides of the triangle, this angle is 25 degrees. So this would be 180 minus 50 or 130 degrees. So we're going to do the law of cosines in here to find the R1. So R1 squared is equal to 150 squared plus 150 squared minus 2 150 times 150 times cosine of 130 degrees. Keep in mind that the angle is angle between the 250 Newton force, which is 130. So now we can find our R1, which would be the square root of whatever we have in the previous step. So I'm just gonna put in the calculator, see what we get. So square root of 150 squared plus 150 squared minus 2 times 150 times 150 times cosine of 130. That's going to be 271.89 newtons, which is our R1. And now we can find the resultant of the R1 and 500. So we have this 500 force in here, and this will be our R1. Again, we are using the triangle rule, and this would be the R that the question is asking, which has to be less than 600 newtons. So we can do the same thing as long as we have this angle. We should be good to go to find the R, to find the angle alpha that the question is asking. And how we can find that angle is that if we continue the 500 Newton force, we know this angle here is 30 degrees. That's what we have in the question. So this angle, and also this angle here would be the angle of horizontal and this, which is basically alpha plus 25 degrees. So now we can find this angle pretty easy. 180 minus alpha minus 30 plus 25, 55. So now we're good to go to do our law of cosines. R squared is equal to 500 squared plus R1 271.89 squared minus 2 times 500 times 271.89 times cosine of the angle 180 minus alpha minus 55, which is going to be 125 minus alpha. So if we want to find the cosine of 125 minus alpha, we have R squared. We know this is 600. So it will be 500 squared plus 271.89 squared minus 600 squared divided by 2 times 500 times 271.89. So let's figure out this value first. So 500 squared plus 271.89 squared minus 600 squared. We're going to divide that by 271.89 times 1000. 89 divided by 1000. So that's going to be minus 0.13 or 133. So minus 0.133. So we have a negative value for cosine, which means we have to find the values of the cosine in the second and third quadrants. So these are where we have the cosine a negative value. So let's see what's the value that we have for cosine that is negative. So one of them is 97.62, which is the value that we have for second quadrant. So in here, 125 minus alpha would be cosine inverse of what we found in the previous step minus 0.133. So this will be equal to 97.62. So our alpha would be 125 minus 97.62, which will be 125 minus 97.62. That's going to be 27.38. And also we know in order to have the second quadrant, this can be equal to minus 97.62, which is going to be somewhere here. So these are the two values that cosine is negative. So 125 minus alpha is equal to minus 97.62 as well. So our alpha would be 125 plus 97.62. So 125 plus 97.62, that's going to give us 222.62 degrees. And these are the values that we have for alpha in order to have our R less than 600. So our alpha would be 27.38 and the upper range would be 222.62. Just to want to confirm the answer, you can go with values less than 27.30 or higher than this and see what you get for R. And if you do, we'll see that you get values higher than 600 for R, which is why this range is acceptable for us. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.